All right, here we go. Question number 3. I have already written down my statements and reasons, so I'm going to look at K, M, and JN bisect each other. That's my given. And so if K, M, and JN bisect each other, bisect means to cut in half. And so I know that I'm going to get a segment that's cut in half or cut into 2 congruent segments, which would be JL and ML if that segment is cut in half. And then if I go the other way from J all the way to N, I see that one's also cut in half. And so I can say JL is congruent to NL, and I can write those 2 statements here. So my second statement is going to be that KL is congruent to ML, and my third one is going to be that JL is congruent to NL. And for 2 and 3, you would use the same reason. And the reason has to do with this up here, bisect. And so we can just write over there for 2 and 3, definition of bisect. Now we need another part that can be named congruent. And so when I look at my diagram, I see I've used up all my givens, so I'm trying to pick out something else that I can use. In the last example, we use the reflexive property, but we don't see that we have a shared side between our 2 triangles. So the other thing we often look for is a pair of vertical angles, and I see vertical angles right there. When I name my vertical angles, it's very important that I use 3 letters. I can't just say angle L. So I would say angle KLJ is congruent to angle MLJ, nope, MLN, sorry. And my reason for that would be they're vertical angles, so they have to be congruent. All vertical angles are congruent. You fill that in on your own. Number 5, we're ready to say that our 2 triangles are congruent now. And so to say that our 2 triangles are congruent, we look at what we've proven. We've proven that a side, an angle, and a side are congruent to a side, an angle, and a side. So you're going to say your 2 triangles are congruent by side, angle, side. You fill in the blanks here. I'm leaving that for you to do. For part B, it says describe the rigid motions that would map triangle NML onto triangle JKL. Well, I see that this would be a rotation, and so if I'm going to do a rotation, I'm going to try to get J to map to N, and I'm going to try to get K to map to M. And it looks to me like I'm doing a rotation around this point here, L. And so you're going to write rotation around L of 180 degrees, it looks like, would map the triangle onto its corresponding triangle. Again, you fill in the blanks.